So if we look at a worked example based on total internal reflection, in this example here we have got a path of a ray hitting a right angle glass prism as shown, and it goes straight through that first surface because it's at right angles to it, and then it hits the second surface as 45 degrees. Now if at this point you then started doing a calculation of n equals sine theta 1 over sine theta 2, basically you would get an undefined value in your calculator, and that's a good indication that either you've made a mistake or more likely that total internal reflection has taken place. And to double check that, what we'll do then is work out the critical angle and see how this angle compares to that. Now you could in theory start every example by working at the critical angle, but it's probably a bit better just to go ahead with the calculations and see what happens. So in this case, if we do sine theta c equals 1 over n was given right at the start, and we get 40.5 degrees for theta c, and then we can make a clear statement that the angle of incidence at the rear surface is greater than the critical angle, so total internal reflection takes place. So the ray will reflect from at 45 degrees. Okay, total internal reflection always means the angle of reflection is equal to the angle of incidence. It won't always be 45 degrees, but whatever angle it's at, it will reflect at the same angle. But in this special case, because that's 45 plus 45, then that's 90, it's a right angle, which means it will then come down and hit this surface at 45 degrees again, which is greater than the critical angle, so total internal reflection takes place again at the second surface, reflects at 45 degrees again, and comes back out that way. Now, this actually is fairly straightforward. A fairly common use of these triangular prisms. They can be used in binoculars and periscopes, but if you even look at simple bike reflectors, then what you quite often see is just bits of plastic with this triangular shape. It's very efficient at reflecting light, more efficient than we can easily make mirrors to be. It does say, notice that had the refractive index been less than 1.41, then the ray would have reflected out at the first surface. It would have come out here somewhere.